Alright, we're starting a chapter on rational exponents, and the first definition that we have here is scientific notation. Scientific notation is a number that's in the form a times 10 to the n. And it's specific that this a here has to be 1 or bigger, but less than 10. So an example for 4.2, 4.399, 1, 9.9. Also specific is this m here has to be an integer. Integers are whole numbers, positive or negative, including 0. No decimals, no fractions. I'll give you some examples of some numbers in scientific notation. 3.4 times 10 to the fifth. It fits it because the 3.4 is at least 1 but less than 10, being multiplied times 10 to an exponent, and that exponent is an integer. Another example, 1.008 times 10 to the negative fifth. Fits the definition. Another one, let's say 9 times 10 to the 0. Also fits the definition. 0 is an integer, and 9 is at least 1 but less than 10. So these three here are scientific notation. These next three are not scientific notation. For example, 0.9 times 10 to the fifth. It's not scientific notation because the 0.9 is not at least 1. Another example, 4 times 10 to the 1/2. It's not scientific notation because the exponent 1/2 is not an integer. Another example, 10 times 10 to the 8th. This is not scientific notation because this 10 is bigger than 10. You can see here it has to be less than 10. So those are the reasons why those are not scientific notation. Next, let's just talk about exponents, the purpose of exponents, and what it means to be an exponent. At some point in the history of mankind, someone got tired of writing the same number being multiplied times itself. Here we have 2 times 2 times 2 times 2 times 2. Someone decided, instead of writing that 5 times, let's just write the 2 one time, and that 2 is called a base. And then, to signify how many times we're going to multiply it by itself, we'll write a tiny little number up top. That tiny little number up top is called the exponent. So 2 to the fifth just means you're going to multiply 2 times itself 5 times. That is the gist of what exponents are. There's some definitions of integral exponents. Integral means that your exponents are integers. One of those rules is the following. If n equals 1, x to the n equals x. An example of that. Let's say that our x is 8. 8 to the first is 8. Another example. Negative 4 to the first is negative 4. And I should say that this negative 4 would need to be in parentheses. So any number whose exponent is 1 is the original number. That's what that definition is. Next definition for integral exponents. If n is bigger than 1, and keep in mind n is an exponent and it's an integer, then x to the n equals x being multiplied by itself n times. The number of x's here is n. There's n of those x's. Example, 3 to the 5th means 3 5 times. There are 5 of those. Another definition of integral exponents. X to the 0 will always equal 1 so long as x isn't 0. Example, 8 to the 0 power is 1. Negative 4 to the 0 power is 1. Any number to the 0 power is 1. As long as that original number, the base, isn't 0. 0 to the 0 power is undefined. Third definition of integral exponents. X to the negative exponent is equal to 1 over x to the positive exponent. Once again, this is as long as x doesn't equal 0. What this essentially means is, if you take any base, doesn't matter what it is, any base, can be a whole number, decimal, fraction, positive or negative, and if you want to change the exponent so it's the opposite sign, you just reciprocate the base. So an example, let's say that we have 5 to the negative 3rd. Our base is 5. If we reciprocate it, we get 1/5. And then the exponent becomes positive. Reciprocate the base, change the exponent. Works in the opposite direction as well. If you have a positive exponent, like let's say we have 4 to the positive 2, and you want it to be a negative exponent, reciprocate the base, change the exponent to be negative. Here are some properties for exponents. These are facts about exponents. Each of these facts are based on the conditions that m and n are positive integers, and that a and b are real numbers. Here's the product property. If you're multiplying two things together and they have the same base, in this case they have the same base as a, you can simply take the exponents and add them together. This is the product property. Example with numbers. Let's say that we had x to the 5th times x to the 7th. That would be equivalent to saying x to the 5th plus 7, which of course would be x to the 12th. The reason that should make perfect sense to you, what does x to the 5th mean? It means that you're multiplying x by itself 5 times. What does x to the 7th mean? It means you're multiplying x by itself 7 times. Add up all the x's, there's 12. By definition, that's x to the 12th. Another property, power of a power property. Power of a power. So you have a base to an exponent, which in turn is raised to an exponent. That will be equivalent to taking your exponents and multiplying them together. Example. Let's say that we have x squared cubed. And that would be equal to x to the 2 times 3, which of course is x to the 6th. Why should that make sense to you? Well, x squared cubed. This cubed here means you have whatever's inside the base, which is x squared, 3 times. So that would be x squared times x squared times x squared. What does x squared mean? It means x times x. So does the next x squared. So does the next one. We have 6 of those x's. Therefore, it's x to the 6th. Next we have the power of a quotient property. Quotient means division or fraction. So it's the power of a quotient. This simply means you can take the exponent and you can apply it to the numerator and the denominator, so long as b doesn't equal 0. If b was 0, you'd be dividing by b, which we've established before is undefined. An example, let's say that we have 4/7 squared, and this is saying that would be 4 squared divided by 7 squared, which you can simplify this to be 16/49. Another property is the power of a product. Product means multiplication. Power of that means that after you multiply it, then you apply the exponent. Well, that is equivalent to taking each thing that you're multiplying and raising it to the power. Example, 4x to the third. That would be 4 cubed times x cubed. 4 times 4 is 16, times 4 more, I believe is 64. That would be 64x cubed. Next we have the quotient property. Quotient means division or fraction. Anytime you're dividing by the same base, you can take the numerator's exponent minus the denominator's, and of course the base stays the same. Once again, this is as long as your denominator is not 0. Example, let's say that we have x to the 5th divided by x squared. That's going to be x to the 5 minus 2, which is x cubed. Why should that make sense to you? Well, x to the 5th means you're multiplying 5 x's. X squared means you're multiplying 2 x's. X divided by x is 1, x divided by x is 1. You're left with x times x times x, which is x cubed. Another definition, b to the 1m. That is equivalent to the nth root of b. Now this is true as long as, let me erase this here, this does not apply to this. This is true as long as b is greater than or equal to 0, and it's also true when n is an integer and it's bigger than 1. And it could also be true in a different case if b is less than 0 and n is an odd number. Those are two different cases. It's true if b is at least 0 and n is bigger than 1. Also true if b is less than 0 and n is odd. Example, 5 to the 1/2 is the square root of 5. Example, when b is less than 0, -2, n is odd, say it's to the 1/3, that would be the cubed root of -2. One more definition, then we just have some examples. Another definition, b to the m divided by n is equivalent to the nth root of b to the m, which is equivalent to the nth root of b to the m. this is true as long as b is not 0 and m and n are integers. Z stands for integers. And also n has to be positive. M and n are integers, n is positive, and b can't be 0. Example, 8 to the 2/3 is equivalent to the square root of 8 cubed, which is equivalent to the square root of 8. I said that incorrectly. Let me restate. This one here is saying cube 8 when you're done, square root it. This one here is saying take the square root of 8 when you're done, cube it. And I wrote those backwards. This is just getting embarrassing. Please forgive me. Got my exponents in the wrong spot. The 3, which was the denominator, goes in the radical. The 2, which was the exponent, or which was the numerator, goes into the exponent. There we go. First one says square 8 when you're done, cube root it. Second one says square 8 when you're done, cube root it. And I wrote the same thing twice. I am just chock full of vitamins at this point. Let me start this over. 8 to the 2/3 is, with 100% certainty, the cubed root of 8 after 8's been squared. Or you could cube root 8, and when you're finished with that, square it. The difference between these two is order of operations. You get the same answer either way. This one here, the first one, 8 squared is 64. The cubed root of 64 is 4. This one over here on the right, the cubed root of 8 is 2. 2 squared is 4. You get the same answer either way, but the order in which you do it in can vary depending on what makes the problem easiest.